All right, forget everything you think you know about robots that just, follow orders. Today, we're going to dive into a world that's, well, it's pretty wild. A world where machines aren't just built, they're grown. We're talking about robots that can actually learn, adapt, and evolve all on their own. Yeah, this is the journey from zero to genius.
So let's just get right to the big question, right? Can a machine, an artificial creation, actually learn from scratch? I mean, really learn, without some human programmer telling it exactly what to do for every single move? Is it possible for it to start with like a blank slate and genuinely figure things out for itself? And to really get why that question is such a game changer, you've got to look at these two paths, these two very different futures. Over on one side, you have programmed limits. This is the old way, right? The traditional robot. It's an absolute master at what it's told to do, but it's completely stuck in that box. It literally cannot think outside the lines. But then you look over at evolving intelligence. And this is the whole new idea, that a machine can innovate, that it can come up with solutions its own creators never, ever dreamed up. Okay, so first, we've got to really wrap our heads around the problem here. We call it the programming wall. And this is the fundamental barrier that's been holding robots back from what they could really be. It's the reason they just can't innovate.
I think about it like this. You can have a robot that's like a brilliant surgeon or a master car builder, right? Incredibly skilled at its one specific job. But here's the catch. Its intelligence is locked in a cage. Yeah, it's powerful, but it's also incredibly rigid. The second you throw it a curveball, some problem its programmers didn't see coming, it just breaks down completely. It's totally stuck behind that wall.
But what if you could just smash right through that wall? Well, that's where things get really, really exciting. This brings us to a whole new way of thinking, a fundamental shift in how we even approach machine intelligence. We're talking about creating robots that can actually evolve. And this phrase right here, this is basically the mission statement. The goal isn't just to build a faster, smarter calculator, no way. It's about evolving beyond programmed limits to achieve genuine intelligence. You see the difference? This is the massive leap from just following a set of rules to something that starts to feel a lot more like, well, like creativity, like real understanding. And how does that happen? Well, it all really boils down to this one incredibly powerful idea, self-optimization. Think of it as the engine driving the whole thing. It's this beautiful, simple loop, right? You try something, you see if it worked, you learn from what happened, and then you try a slightly better version the next time. And it does all of this on its own. The machine literally becomes its own teacher, constantly getting better and better, and no human has to go in and tweak the code.
So I know what you're thinking. How does this actually work? It sounds a little bit like science fiction, right? Well, let's pop the hood on what we're calling the learning engine and actually see how a robot can start to build its own brain, pretty much from the ground up.
Okay, so it really comes down to two key things working together. You can't have one without the other. First, you've got the software. Think of this as the foundational algorithms. It's kind of like the basic DNA that gives the robot the rules for how to learn. But then you have the hardware. This is the robot's body, and it has to be a special kind of body, one that's designed to change and adapt. I mean, think about it. You can't evolve a better way to walk if your legs are, permanently bolted in one position. The body and the brain, they have to evolve together. And this is that learning loop we were talking about in action. So step one, it just takes in a bunch of raw data from its environment. Step two, it tests a potential solution. It literally just tries some. Step three, it analyzes what happened. Did that work? Why or why not? And then here's the magic part. Step four, it self-optimizes. It makes one tiny little improvement, and then it runs the whole loop over again, and again, and again. And with every single one of those cycles, it gets just a tiny bit smarter.
So where is all this heading? What happens if you let that learning loop just run? Not for a few hundred times, but for millions, maybe even billions of cycles. Well, what you get is something that starts to look like the path to genius. So let's talk about the ultimate goal of all this.
Now, when we say genius, let's be super clear. We are not talking about like a high IQ score. This is something different. We're talking about a state of complete autonomy and incredible adaptability. It's the ability to face a problem that no one has ever seen before, actually understand it, and then invent a totally new solution right then and there. So what does that actually look like in the real world? Well, it's about solving problems with a level of complexity that just completely overwhelms the human brain. Think about designing a brand new life-saving drug from scratch, or building a climate model that's actually accurate. Or imagine a robot that could literally change its own body to adapt to a new environment, just like that. We're talking about innovating solutions that we can't even imagine yet.
And all of this, it leaves us with one final and kind of profound question. If a machine actually reaches this level of autonomous adaptive genius, what will it choose to do? What problems will it decide are the important ones to solve? What will it want to create? Honestly, that's a future we are only just beginning to even think about.